Op Garage Racer, here comes another dose of useful information, a series about BMW engines. Today, we have a specimen from the fading era of naturally aspirated 3-liter gasoline BMW engines. This is the N52 engine. We will tell you how BMW modernized and thereby complicated its legendary inline-6 gasoline engine, thus tarnishing the reputation of the Nicholas series engines compared to the Michael series. And we will share real repair experiences of these engines at our service centers, unlike the information you might find online. So I think it will be useful and interesting for everyone. Get your popcorn ready and let's go. The N52 began production at the end of 2004. It replaced the much-desired and legendary M54 engine. Back then, the M54 was aluminum with liners and had dual Vanos. It was a generally trouble-free, reliable engine that easily lasted 300,000 kilometers. At that time, BMW was solidifying the reputation of its 3-liter inline-sixes. Before it was the M52, which wasn't as successful. And before that, there was the legendary M50, which is what everyone used to make turbocharged engines. It had a cast iron block and was very reliable. The M50 engine was known to last up to 1,000,000 kilometers. So after the M54, BMW started producing the N52. And that's where BMW's reputation started to falter. We'll explain the nuances and why this happened. The N52 ceased production in 2011. It was replaced by our most popular gasoline engine, the N20, a 2-liter 4-cylinder turbocharged engine. This makes sense in terms of power because look, the N52 was usually produced in 3 versions. There was a 2.5-liter version with 218 horsepower, a 3-liter version with 258 horsepower, and a top-tier 3-liter version with 272 horsepower. And here, BMW faced a question: how to make it more economical, more environmentally friendly, and more productive. They came up with turbocharging, thus the N20 appeared. It removed 2 cylinders, reduced the displacement by 1 liter, and added a turbocharger, and it improved all the characteristics. This explains why the era of naturally aspirated engines ended. The turbocharger proved to be more efficient with direct injection. The N52 itself was used in many models, from the 1 series to the X models. It was used in the 1 series, 3 series, E90, E92, 5 series, E60, and 6 series. Let's look at a specific example. This is an E63 630i with an N52 engine. The owner has driven it from 100,000 kilometers to 230,000 kilometers. So I think their experience is valuable information in practice for potential buyers or current owners of the N52. It was also used in the 7 Series E65. These large big vehicles are very rarely seen nowadays. This includes the 730i version. And of course, it was used in the pre-facelift X5 models. We have a specific example of such an X5 E70 model. It's an American model from 2007, a 3-liter engine. It was also installed from 2010 on the F series, so it's quite common among our clients. This includes the F25 X3 from 2010-2011 and the F10. So when you see a 528, know that if it's from the early years of production, it has the N52 engine. If it's later, it has the N20 point. Our country is at war, and until recently, there was a big problem with gasoline. The only ones who didn't face this issue were the owners of cars with LPG systems. It was easy to fill up with gas, and the prices weren't as high. So this topic about LPG might still be relevant for some. Plus, there are LPG enthusiasts who think it's great to install LPG. For these BMWs with this engine, it's the last reasonable option where you can install LPG without any problems. This is because it has a standard injection system, not direct injection. You can install LPG on it just like you could 20 years ago, with no nuances. There are nuances with the N20 and N55 engines, where they have a turbocharger plus direct injection. We sometimes see such examples, but there's no point in installing LPG on those. If anyone is interested in the topic of installing LPG on the N20 or N55, I can cover it in a separate video. Leave comments and likes. but I think only about 1% would be interested in that. As usual, we start with the engine's components. To reduce weight and improve efficiency, BMW decided to radically change its predecessor, the M54. With the N52, BMW decided to experiment a lot. They made an aluminum insert inside the block where the cylinders are and an external magnesium frame. Magnesium is much lighter than aluminum, and I think BMW decided to reduce weight this way to achieve the best power to weight ratio. Not power per liter, but power per kilogram. They made magnesium parts because magnesium is much lighter than aluminum. The aluminum parts were made without cast iron sleeves, using an interesting alusil coating. For those who are familiar with BMW, remember the M52, which had a nickel coating. It had very bad reviews with scoring and high oil consumption, making the engines difficult to rebuild. You couldn't bore out the cast iron sleeve to fit an oversized piston, which would give you a new engine. With the M52's nickel coating, this wasn't possible because nickel couldn't be bored out. BMW fixed this mistake with the M54 by using cast iron sleeves, and with the N52, they tried a new alusil coating. Based on the experience with the M52, this threatened to have bad consequences, such as scoring after 100,000 or 150,000 kilometers, rendering the engine unusable. But let's see how it actually plays out in practice. What happened in reality? We now have an engine with 230,000 kilometers. Here we have another engine with 180,000 kilometers. They don't consume oil excessively, and even if there is some scoring, it's minor and not significant. This coating is better than the nickel on the M52, so there's no need to worry about excessive oil consumption. The oil consumption issue is more common in the 2.5-liter versions, like the 325 and 525. There you might have problems with oil rings sticking, requiring either decarbonization or replacement of the rings. But today isn't 2010, it's 2022. Objectively, there are far fewer cars with this engine coming into the service stations, and they're not that expensive. They now cost around $6,000, $7,000, or $8,000. X models still go for over $10,000. And it turns out that 6 Series E63 still cost over $10,000. If owners experience excessive oil consumption, they are likely not going to opt for expensive repairs, as it would require a significant amount of money. Several $1,000s. Plus, our country is at war, so usually owners with such problems just leave and try to sell the car or something like that. I'll share an interesting detail that I once encountered. About 4 or 5 years ago, when I was working in my first garages, I had to rebuild an N52. It was a 3-liter with 272 horsepower installed in an E83, which is an X3. I ran into the problem that you couldn't use steel bolts in a magnesium block. Everyone was used to removing a steel bolt and installing a steel bolt. But due to metal corrosion issues, if you screw steel into magnesium, over time the molecules start to react with each other, leading to problems. This is a chemical reaction. Because of this, BMW, in their effort to lighten the engine, used magnesium. Therefore, they had to replace the steel bolts with aluminum ones. You can imagine the reliability issues with aluminum bolts. It got to the point where when you removed and reinstalled the oil pan, you had to use new aluminum bolts because the old ones would already be cracked or broken. It was crazy. When I removed the cylinder head, I unscrewed the valve cover and saw that the main steel bolts holding the head in place were screwed into the aluminum part, while the part at the front where the timing mechanism is located was magnesium. And the bolts there were aluminum. One of those bolts had already lost its head, which had been floating around in the oil pan. I remembered another scary detail. Since the cylinder head is held by the main steel bolts, everything should be fine even if a head breaks off. This might just result in a minor oil leak during assembly. But I found something funny in the oil pan. The oil pump. If I remember correctly, the oil pump was attached with 3 aluminum bolts. It was quite difficult to find them in Ukraine, but we managed. There was a risk that you might screw them in wrong. If your oil pump falls off, you can imagine what would happen to the engine. So the design wasn't the best. If the oil pump bolt heads fall off like the cylinder head bolt head did, it would be a problem. I also remember there was a similar issue with the oil filter housing. It was attached to the block with a single aluminum bolt that had a tricky thread, either M9 or M7. I had a hard time finding a suitable replacement. In the end, I think I bought stainless steel bolts to reduce the chemical reaction. This would last for a few years, but what happens after that is unclear. I screwed them in, but nowadays we would use aluminum or something similar depending on the client's preference. There's no clear evidence of how long it takes for a steel bolt to corrode in magnesium, 10 or 20 years. Garage mechanics who work quickly might not delve into these details and simply replace aluminum bolts with steel ones for immediate reliability, not worrying about the future. The owner of this car suggests reusing the same aluminum bolts, and I partially agree. When you remove the bolts, they can develop cracks. Sometimes the head might just fall off when you unscrew it, and then you have to remove the bolt body separately. Cracks can appear on the head, and as soon as you start screwing it back in, it might break. Those who didn't study this topic or worked in garages might have silently replaced aluminum bolts with steel ones or reused old bolts without understanding the consequences. There are nuances. Heads can break during unscrewing or screwing. Plus, the bolts stretch and the heads can break. So, it's a serious issue that needs a serious approach. According to BMW's instructions, every aluminum bolt needs to be replaced and tightened with a specific torque and angle. To conclude with the block, I'll mention a case with an N52 that had 350,000 kilometers on it. When it was taken apart, the alusil cylinder walls were in excellent condition, like a mirror. Of course, there wasn't a honing pattern like on cast iron sleeves, but it was in good condition without any scuffing. The takeaway here is that much depends on the quality of maintenance, how often you change the oil and what kind of oil you use. And the engine is thermally loaded, therefore the oil needs to be changed frequently and it should be high quality oil. Additionally, it depends on the fuel, like the amount of sulfur additives, which can damage the coating. Overall, the cylinder coating is not a weak point of this engine. Regarding the cylinder head construction, BMW made significant changes. They introduced the Valvetronic system, which wasn't present in the M54. It was supposed to improve torque and fuel efficiency by replacing the throttle. The throttle is still there, but while previously the engine operated via the throttle, you press the gas pedal, the throttle opens before the intake and air flows in. Here the throttle is always open. It only closes in emergency modes or when the engine needs to be shut down. The role of the throttle is now played by the intake valves, which have a variable lift system ranging from a minimum of about 0.35 millimeters to a maximum of 9.7 millimeters. So, when you need full power, the valves open fully. For idle, they open minimally. This essentially replaces the throttle opening. This system allows for better fuel economy and a quicker response to the gas pedal. It includes an additional intermediate eccentric shaft between the intake and exhaust camshafts. The intake camshaft pushes on intermediate rockers, which we'll show schematically. You might think, well, this complicates things with around 30 additional parts. Yes, and all this is controlled by an external electric motor. The motor uses a worm drive to adjust the eccentric shaft. What problems arise? Up to about 100,000, 150,000 kilometers, usually none. Everything works fine and owners of new cars are happy with better fuel consumption. For instance, the E60 came with the M54 engine, and later models had the N52, giving newer car owners lower fuel consumption. However, after 150,000 kilometers, additional issues arise. The worm drive of the electric motor wears out, as does the motor itself, and the connection between the eccentric shaft and the motor also wears down. Ideally, we recommend replacing the motor first if there's an electronic issue because it's accessible without removing the valve cover, unlike the N42, N20, or N55. You can easily replace the motor from the outside and check if it helps. However, it's common that just replacing the motor doesn't fix the issue, so we recommend replacing the shaft. The shaft costs around $1,000, similar to the N55. When owners hear this amount, considering the car's value, not everyone is willing to spend that much on such an expensive repair. Unlike the owners of N55 engines, where things are still generally fine, for the N55, we always recommend replacing both the motor and the shaft together. If the valve cover is already removed, we change both parts at once. Now imagine you have an N52 engine with over 150,000 kilometers. If you experience issues like uneven starting or rough running, where the engine misfires randomly across different cylinders, and you've already checked the spark plugs and coils, but the problem persists without any error codes, it's likely due to valvetronic issues. When the motor fails, there are no error codes in the ECU because the brushware residue affects the motor's resistance, leading to erratic behavior without being detected by the ECU. Another common problem with this engine's hardware is the VANOS system. VANOS is the variable valve timing system. It has two main gears on the intake and exhaust camshafts, controlled by oil flow through specific channels and valves. These valves regulate the oil flow, either allowing or restricting it, and there are two filters before these valves to catch coking particles. If you haven't changed the oil for a long time or are using poor quality oil, the engine can start to coke up gradually. And some oil particles end up in the oil system, in the oil delivery system. As a result, this mesh gets clogged with these contaminants. How do issues with VANOS typically manifest? Your engine may run unevenly, display VANOS-related errors, experience rough idling, or have difficulty starting. So, in that regard. And what does BMW recommend? First, there might be an issue with overall oil pressure. So, start by checking the oil pressure and oil level. Here's an interesting feature of this engine compared to its predecessor. BMW decided to eliminate the oil dipstick altogether. Yes, it's gone. Now you rely on the electronic dipstick. Unfortunately, this has caused headaches for owners. The oil level sensor can sometimes show incorrect readings. Owners might think everything is fine, but in reality, the oil level could be dropping gradually. Low oil levels can lead to poor performance. Once a car came to me during the first few months of my work. I believe it was an N42 engine. Similar system, it was running rough. Turns out it had only half a liter or a liter of oil left. Quite a situation. So that's the first thing to check, pressure and level. Second, proceed step by step. Oil flows through screens located near the exhaust manifold. Inspect and clean those screens. Next, remove the VANOS solenoids. Clean them too. Examine them to identify any issues, whether intake or exhaust VANOS. If needed, you can swap them around. Determine which one is the valve and which one isn't. By the way, this engine has already encountered this problem. The solenoids have been replaced. And then if everything else is done, you might need to delve into the VANOS actuators themselves, which are costly, about $300 each. Those were the VANOS issues and those components. But the engine iron quirks don't end there. Of course, owners often remain unaware until they have to dismantle the engine. One common problem is wear on the exhaust camshaft lobes. Again, it's related to oil delivery. The exhaust camshaft sits in its housing and wear occurs over time. This wear might manifest as an unusual sound, like a faint rustling, but many owners don't realize the extent of the damage. There can be actual scoring on the camshaft lobes. I encountered this issue while disassembling an X3 E83 with the N52 engine. We initially addressed one issue, but when we removed the exhaust camshaft, we discovered a different problem, those scoring marks. And then we searched for a very long time at the junkyards for this exhaust camshaft. And there was such a problem that the dismantlers didn't want to dismantle the engine until we dropped the prepayment. They weren't sure if it would be damaged or not. Eventually, the owner ordered a replacement from abroad, which took a month and cost around $1,000. Another challenge was related to gaskets and seals. Compared to its predecessor, this engine had issues with gasket leaks. BMW raised the average operating temperature for efficiency and environmental reasons. The normal operating temperature is around 112, 115 degrees Celsius. If you push the engine hard, the thermostat opens, the water pump kicks in, and the temperature drops. But back then, nobody was accustomed to such high-temperature engines. Owners started encountering leaks in oil pan gaskets, valve covers, and crankshaft seals after about 100,000 kilometers. Plus, there was the oil filter housing gasket. These leaks led to increased oil consumption. Some thought it was related to the alisyl coating or carbon buildup. However, the solution often involved replacing the oil separator seals. Don't forget, there are valve stem seals in the cylinder head. Due to the elevated temperature, they wear out quickly. Recommendations varied, but replacing them between 80,000 and 150,000 kilometers was common advice. Perhaps this information comes from Russian forums, where traffic congestion might lead to more engine hours. In our reality, specifically at our service center, we typically replace the stem seals around 150,000 to 200,000 kilometers. By the way, when did you change them? You didn't change the valve stem seals? Didn't you? You did. Didn't you? Whoa, well, it turned out that the owner of this car with 230,000 kilometers had never changed the valve stem seals. That's weird, really weird. Anyway, as you can see, there are different cases. Generally, it's recommended to change them around 150,000 kilometers. So if you're consuming a liter of oil per 1,000 kilometers or 3 to 4 liters per 10,000 kilometers, it's very likely that your valve stem seals have hardened significantly. 5 years ago, this was a very popular procedure, or even more years ago when these engines were in trend, before the F-Series and turbocharged engines. People thought the N20 and N55 engines would be even more problematic due to their complexity, direct injection, and turbocharging. But it turned out that we almost never replace valve stem seals on the N55 or N20, even after 200,000 kilometers. Surprisingly, they don't consume oil. In terms of hardware, we still have the valve cover. In pre-facelift E60s, the first modification of the N52 without the N has a magnesium valve cover. What's the difference for the owner? Not much, except that the crankcase ventilation valve is placed under the intake, which we will explain in the air supply system. The advantage of the magnesium cover is that it doesn't crack or warp. In plastic valve covers, the CCV membrane can tear, and while it can be replaced separately, it's generally recommended to replace the entire valve cover. Additionally, leaks are common after 100,000 kilometers, and sometimes the valve cover itself can crack. I remember a case 4 or 5 years ago where I personally replaced such a valve cover, and it cost about $400. And of course, we cannot forget about the pressing issue for N20 owners and diesel engines. Its timing chain. In the N series, chains are recommended to be replaced after 200,000 kilometers. There can also be issues with plastic components, similar to the N20, where the plastic may break apart and fall into the oil pan. Therefore, we recommend checking this after 200,000 kilometers. Additionally, BMW offers a version of the N52 engine labeled as N51, which some might ask about in the comments. The main difference is that there is no additional heat exchanger on the oil filter housing. So, the oil filter housing is bare, without a heat exchanger, meaning there's one less gasket to replace after 100,000 or 150,000 kilometers. According to our checklist, we move on to the air supply system. Unlike our previous reviews, this is the first naturally aspirated engine, which will be somewhat simpler on one hand but more complex on the other. Air usually enters through the MAF sensor, and then, instead of going to a turbocharger, it goes directly to the intake manifold. At first glance, this simplifies the system since there's no turbo, no oil leaks, or similar issues. However, the intake has interesting changes and additions compared to its predecessor and even compared to the N20 and N55. This system is called the variable length intake manifold. Why was this implemented? A bit of theory. I once read a book on internal combustion engine theory, which stated that the optimal air mixture speed in the runner of the cylinder head right before the valve should be around 120 kilometers per hour or perhaps 90 kilometers per hour for optimal cylinder filling. Essentially, to fill the cylinder as efficiently as possible, a certain airspeed is required. You understand that with 6 cylinders running at 600 RPM at idle or 6,500 RPM under heavy load, the airspeed and air delivery time through the intake manifold vary significantly. Therefore, BMW decided to implement a variable length intake manifold to optimize the air mixture speed and delivery time. They installed 2 flaps known as DISA valves, which allow for smoother torque delivery. This kind of filling roughly evens out the torque curve across the RPM range, making it smoother. So if the torque curve used to be like this, with the DISA it becomes better. However, owners usually don't care about this, but it does affect fuel consumption and the engine's responsiveness at low RPMs, for example. After 100,000 kilometers, there can be issues because the DISA valves are plastic, and the flaps can break off and get sucked into the manifold. Therefore, we recommend inspecting your two DISA valves at such mileage. The catch with DISA valves is that when the flaps start to become loose or break off, there are no error codes and you might never know. You might feel a slight decrease in power in some situations, but few will notice. The main issue is that the DISA flap or the axis can fall off and enter the cylinder or valve, leading to major engine repairs. About 5 to 10 years ago, such incidents were common. BMW made 3 modifications to the DISA valve, and since 2007, the latest version is designed so that even if the flap breaks off, it doesn't go anywhere, and the axis doesn't fall off, thus preventing engine failure. By the way, at 120,000 kilometers, the large DISA valve on this car was replaced because the flap fell out. Generally, the larger valve is replaced more often because it operates over a wider range. Let's move on to the ignition system. It's simple. There are coils, individual coils for each cylinder. There are plugs. The plugs, as usual, are changed every 60,000 kilometers. And BMW has decided to play with coils here, not for the better. That is, if on predecessors on Michael series coils were reliable and almost never broke down, maybe their 200,000, 300,001 will break down there if it breaks down. Here, BMW just introduced this new type of coils, which went further. On all the Nicholas, on N20, on N50, the same type of coils, and only on the B series has it changed the type of coils. So these are coils that can break even at 100,000 kilometers of mileage and start to a lot of constant serial breakdowns. That is, that are more likely to be replaced more often. But they're inexpensive and it's not really a big problem for the owner at all. In the past, by the way, we used to keep such reels in stock. A customer would come in with a misfiring N52 or N52 or N42. We'd throw the coils in and everything was fine. Everything was solved. Let's move on to the fuel system. It's simple here. The engine uses standard fuel injectors with 1 injector per cylinder. The injector sprays fuel into the intake manifold where the mixture begins to form. The fuel is injected into the intake where it gets mixed with air and then enters the cylinder through the open intake valve. In direct injection, the injector sprays fuel directly into the cylinders. Regarding the fuel system, it's straightforward. There's a submerged pump in the tank with a filter and level sensor in one half of the tank. On the other side, there is a filter and sensor in the other half of the tank. There are no filters in the fuel lines. Fuel then flows to the rail and 6 injectors. Unlike the M-series engines where separate filters needed to be changed at each service or every 3 services, this engine does not have a separate filter that requires regular replacement. This engine marked the beginning of the N and B series gasoline engines, which do not have a separate fuel filter that needs to be changed regularly. Regarding the components of the fuel system, everything is reliable here. Nothing typically breaks down. The fuel injectors on BMW engines usually don't fail. Cleaning them doesn't really help if they are already damaged. When we first opened the service center, we bought a stand for cleaning injectors, and over time, I never had to clean any injectors from BMW engines. There weren't many issues with them. Moving on to the exhaust system. Unlike turbo engines, it's straightforward here. There's a single exhaust manifold that combines 3 into 1. The first bank consists of the first 3 cylinders, and the second bank includes the 4th, 5th, and 6th cylinders. Each bank has its own catalytic converter, and they are ceramic. There's a risk that the ceramic can start breaking down and be sucked into the cylinder, potentially damaging the engine, so it's advisable to either replace or remove them. This usually depends on the condition of the catalysts, how the car has been driven, and the type of fuel used. It might be necessary to address this issue after around 150,000 kilometers of driving. Around 180,000 kilometers, all the catalysts were removed, converting to Euro 2 emission standards. Since there are 2 catalysts in the system, there are 4 oxygen sensors, 2 before the catalysts and 2 after them. The rear sensors have been disabled. By the way, recently, after 200,000 kilometers, the driver replaced the oxygen sensors. Well, just in case to ensure proper mixture formation. Moving on to the coolant system. Here there are indeed more problems compared to the M series. This is due to the engine being more heat stressed. Plastics on the radiators and hoses dry out faster. The rubber gaskets on the hoses also deteriorate more quickly. Plus, there's a higher chance that the coolant reservoir might crack, for example. By the way, the E70 model is notorious for this issue. We used to keep that reservoir in stock regularly, and we'd replace it on the E70 about once a month. Hoses, of course, can fail with age. Generally, there aren't any major issues, but BMW decided to make a change here, again for the sake of economy, ecology, and quicker heating. BMW introduced an electric water pump. This is actually the first engine with an electric water pump. Previously, mechanical pumps were used, which were reliable and worked well. Here, imagine that during warm-up, for instance in winter, the pump doesn't activate until a certain temperature is reached. Plus, the pump operates at different loads depending on the engine's temperature regulation in various modes. You might know that in the M-series engines, there was an issue with the expansion tank caps. They were recommended to be replaced annually because they could seize up, leading to overheating and similar problems. In this engine, BMW has already changed the cap design, so it doesn't need to be replaced as frequently. However, we still recommend replacing it every 2 to 3 years because it can still break down over time. Of course, the cornerstone of the coolant system is supposedly the electric pump. Some might say it fails prematurely, but in my experience, we either haven't replaced them or they were replaced after I stopped managing the service center. Overall, it's not a major problem considering the mileage. I can confidently say that it can last up to 200,000 kilometers without issue. There is also a thermostat in the system. No particular reliability issues have been noted. Everything is generally fine. Regarding our specific instance, with 230,000 kilometers on the clock, the front radiator hose was replaced due to age. The car has traveled extensively in Ukraine, which also plays a significant role. For example, this X model, with 183,000 kilometers, recently arrived in the USA, and it came from Ukraine costing around $1,000 or $1,500. Therefore, with such mileage, there will definitely be much less wear. Probably nothing from what we've listed has been replaced. Moving on to accessory equipment. Everything is standard here, but unlike the F-Series, this model has a hydraulic steering rack and power steering. From experience with the N52 engine, the power steering pump doesn't last as long, and it might need replacement around 150,000 kilometers. The alternator is usually fine, and the air conditioning compressor typically performs well. As for the starter, I recall that the owner of this vehicle has already repaired it. For the belt rollers, we recommend replacement every 100,000 kilometers as a standard practice. Let's move on to the chip tuning section. There should be some dramatic sounds here because naturally aspirated engines don't respond well to chip tuning, and it's generally not very effective for them. What's the catch? For this engine, you can typically achieve about a 15% increase in torque and approximately 5 to 7% increase in power through chip tuning. This is done by adjusting ignition angles and other parameters, which requires using higher quality fuel. In other words, cars factory tuned for 95 octane fuel can be modified to run on 98 or 100 octane fuel, potentially adding 5 to 7% more power. Owners may not notice much of a difference, but could encounter additional issues such as possible detonation or irregular performance. Considering the current war situation and poor fuel quality, it's not recommended to pursue this. The cost of chip tuning and the exhaust upgrades required often aren't worth it, so it's generally avoided. However, there are interesting options for owners of the non-top version of the 3-liter N52 engine. There are 3 versions of the 3-liter engine. One with 272 horsepower, another with 258 horsepower, and in this case, 252 horsepower. And there are also the American versions, for example, the 328i models, which come without DISA and have 233 horsepower. So, for the 252 horsepower version, you can use an aftermarket approach to achieve 272 horsepower. For the 233 horsepower version, you can change the intake manifold, install DISA from the 3-liter version, and flash it with the 3-liter software to get 272 horsepower. However, as far as I remember, no one is really doing these modifications anymore. The focus has shifted from the N52 to the N20, N55B series turbo engines, where a simple stage 1 chip tune can achieve a power increase of 20 to 30%. So overall, to summarize, The golden age of these engines has passed. It was around the 2010s, maybe up to 2015. Compared to the M54 engine, this engine was heavily criticized, especially considering the 2.5-liter version, which had issues with carbon buildup on the rings. Even after replacing the valve stem seals, there were still problems with oil consumption. For example, if you had 5 liters of oil consumption per 10,000 kilometers, replacing the valve stem seals might reduce it by a couple of liters but still leave a few liters. The main issue was generally solved by replacing the valve stem seals, which would eliminate oil consumption. During that time, the reputation of BMW's gasoline engines was tarnished by the N52 engine compared to the M54. Meanwhile, the BMW diesel engines like the M57 continued to be produced into the 2010s with few changes except for chain replacements after 300,000 kilometers. Reviewers of that time recommended only diesel engines, saying the gasoline engines were bad, and they particularly recommended avoiding the N-series gasoline engines. The M57 3-liter diesel engine gained even more fame and recognition, and everyone wanted a car with that engine. But personally, my impression of the N52 doesn't quite match the negative reviews from when I didn't have a service center. It's similar to my initial view of the N47 engine. Before having a service center, I thought it was terrible, but after having a service center, the situation was not as bad as I had thought, though it wasn't great either. I would rate the N52 engine as a 4 out of 5. In reality, we don't encounter all those problems consistently, like frequent engine replacements or breakdowns. For example, a car with 230,000 kilometers with 100,000 kilometers from one owner who drove it in Ukraine has held up quite well. And here, well, the valvetronic motor was replaced, the dicer was replaced, and one Vanos valve was replaced. The valve cover, by the way, is magnesium and doesn't need replacement or crack. So, from the entire list we discussed, 3 parts have been replaced here, and those are related to metal components and accessories. Overall, the result is excellent. And considering that the car hasn't been driven all the time in Ukraine, imagine a fresh American E70 that came from the US with 185,000 kilometers. In theory, nothing might need to be replaced up to 250,000 kilometers. But you need to inspect everything we mentioned to ensure it's all in good condition. It will definitely last longer. Americans, of course, usually drive longer distances in one go. Their average speed is higher than our stop-and-go traffic in Kyiv. Therefore, the engine has fewer operating hours, gaskets haven't dried out as much, oil hasn't carbonized as much, and the valvetronic hasn't worn out as much. And that's all the systems covered. So this will be good news for owners of US cars. For example, the E90, E92. The 328i is a popular model. In Europe, these models didn't exist at all. They were designed specifically for the American market. So that's good news for them. The same goes for owners of F-Series cars with such engines. Generally, besides replacing valve cover gaskets, maybe the valvetronic motor and the PCV valve, nothing much happens. Regarding differences in metal components, there was an American version with the N51 engine. Personally, I think the horror stories from reviews and the internet don't match the practical experience. If you have an N52, particularly the later versions up to the 2010 model year, with relatively low mileage, there aren't many problems. In the worst case, it might be the valvetronic motor or a Vanos valve. But again, that's if you experience irregular operation. You could also check the DIS. Overall, there's nothing to fear. Just make sure to change the oil on time. We recommend changing it approximately every 7,500 kilometers for city driving. Some people change it at 6, 7, 8, or at most 10,000 kilometers, and then you'll always have a clean engine. It often happens that when cars come from Europe with service intervals of 30,000 kilometers or even 25,000 kilometers, it can be really tough on the engine. Therefore, we recommend checking the condition of your engine and then making a decision. More frequent oil changes might be beneficial, and it could be worth considering flushing the engine to prevent potential issues with engine performance, such as Vanos system problems, oil supply issues, and to avoid scoring on the exhaust camshaft and carbon buildup. In summary, I'd rate the engine at a 4 out of 5. If you take good care of it, everything should be fine. The issues we've mentioned might affect you by about 10 to 20%, depending on the situation. Some people might experience one set of problems while others might face different ones. Finally, last thought from the garage racer's perspective. Before running the service station, I thought the N52 was a terrible engine. And then, with the N20 and N55, they added turbocharging and direct injection, which I assumed would make things worse by exacerbating the issues of the N52 engine. However, it turned out differently in practice. The issues with the N20 and N55 engines didn't seem to be inherited from the N52, even though they are similarly high-stressed engines with comparable temperatures. Perhaps it's because our clients change their oil regularly, keeping the engines clean and functioning well. Issues with the metal components are usually not encountered. There might be additional problems related to the fuel system, but we have plenty of other videos on that topic. Check out our videos on the N20 and N55 engines for more details. When my subscribers ask what I think about the N52 engine, especially since we haven't done a review until now, I usually summarize by saying that the main issue could be with the Valvetronic system. This can cause the engine to not perform optimally. So I want to reassure current and future owners, especially those with newer engines like in the F-Series models, that there's really nothing to worry about. There might be a few problems, but nothing major. Rest easy. It would be great to have Arestovich on this review. He could explain the N52 in such a way that you'd all sell your BMW M57 diesels and switch to the N52. But unfortunately, I'm not that good at explaining things. Don't forget, the country is at war. Support volunteers, the Territorial Defense Forces, and the Armed Forces of Ukraine. Glory to Ukraine, death to the occupiers. And now, let's get to work.